Hey folks, I wanted to give you a quick video where I give you an angled launch problem and work through it. And when we're done, I want you to try and work on the angled launch problems that I gave you in class last week. That's on Google Classroom. There's 4 problems on there, and I want you to try the first 2 today. So here's a problem that's not on that sheet. That is a launch at an angle, and I'm going to walk through the 5 parts of solving this problem. What you want to recognize is that the first 3 parts are things you'll do every single time, kind of just as a rote thing. The last 2 things will change, and so the worksheet will take you through these decisions, and then eventually we'll want to look at making your own decisions about how to solve a problem. But we have a problem where a soccer ball gets kicked. We know the speed and angle of launch, and we want to know how far away it goes. So to draw and label a picture, so here's our soccer pitch, and there's the ball, and the ball is going to get kicked at a certain angle. And so the trajectory of the ball is going to look like a parabola. And again, it does that because of acceleration due to gravity. It's in free fall as soon as it leaves the ground. The reason we draw the picture is to label it with our x and y coordinates. So the ball starts at a horizontal location of x naught and ends at a horizontal location of x. And so it's pretty easy to see. If you kick a ball, it's going to fly through the air and like land away from you some distance. What's different about this picture as compared to the other, like the horizontal launch problems, is that the initial vertical position and the final vertical position are in the same location. In other words, the soccer ball starts this problem on the ground and ends on the ground. Even though it goes up in the air, its initial height is 0 and its final height is 0. And that's going to come into play a little bit later. So that's part A of this problem, the picture. If you haven't had time to copy things down, maybe pause the video and unpause when you're ready to go. Okay, part B is the trig. And so what we have V naught is 21 meters per second, and the angle of incline is 25 degrees. And so I want you to use these kind of trig formulas. Now that we've done all the trig, I want you to use this fact. Vx naught equals V naught cosine theta. The idea behind this equation is when you kick something at an angle, it is moving both forward and either up or down. We do trig to figure out how fast it's moving forward separately from how fast it's moving up or down. And so this is you think of it as the forward velocity, okay? And the way the trig works is we plug in just 21 meters per second times the cosine of 25 degrees, and Vx naught equals 19 meters per second. So just kind of like apart from the math, I want you to notice that how close this value is to the 21. When you have a very shallow angle, the x velocity is very close to the total velocity. We would think of 21 meters per second as the total velocity in the direction it's actually moving in, and a large part of that is the horizontal velocity. There is also an upward portion to the velocity, and so Vy naught is equal to V naught times the sine of the angle. So we plug in the same numbers, 21 meters per second times the sine of 25 degrees, and we get this, there we go, we get this vertical velocity of about, it's 8.9 meters per second. So these are the initial velocities. These are the components of the initial velocity. So it's moving 19 meters per second away from the person who kicked it, and it's also moving 8.9 meters per second away from the ground. And so it's doing both of those things at the same time. So the purpose of all this is to break apart the velocity into horizontal and vertical components. Okay, next part would be to establish a data table. And so we have X and Y values. We have 4 variables in the X direction, and we have, we're going to just use 5 variables in the Y direction. And I think that'll make things a little easier for us. So we can put in the initial and final positions based on our picture. So we want the point where the ball starts to be 0 for as many dimensions as possible. So we're going to say that x naught is 0 and y naught is 0. The idea behind this is we want these values, we want as many things as possible to be 0. And we can make any point in our picture the origin of our picture. And so we decide, why don't we make the ball, its initial location, the origin. So the furthest to the left we get in the picture is 0 meters, and the furthest down we get in the picture is also 0 meters. If this is the origin, then the x-axis stretches off to the right, and that means that the value of y is also going to be 0 meters. It starts and ends at the same height, even though it doesn't land in the same exact location, it lands in the same height. We don't know the value of x, but in fact, that number is going to be the answer to our question. We did some trig. We found that Vx naught is 19 meters per second, and that Vy naught is 8.9 meters per second. So this always comes from our trig. And then acceleration in the y direction is negative 9.8 meters per second squared. So that's the data table. A lot of you have said that's the hardest part for you. And so, you want to ask questions if you have them, but the positions are all based on your picture. If we insert the y-axis and the x-axis into our picture, we can see that y naught and y are 0, and that x naught is 0 also. So that's the positions. The velocities come from trig, and then acceleration is always the same. The last part is to find time and then find the value of x. So if I just kind of look at this, the reason I'm going to use the next equation is because I have 4 known values in the y direction and only 2 in the x. So I will use this equation. We've done this a couple times in class. The algebra is like a little tricky, but it's not too bad. So 0 equals 0 plus 8.9t plus 1/2 times negative 9.8 times time squared. Oops, this should be a plus sign. So that simplifies to 0 equals 8.9t minus 4.9t squared. So this is a quadratic equation, but it's one that you can kind of factor your way out of. In other words, I can say 0 equals, and I can divide, or I can factor out a t here, and say t times 8.9 minus 4.9t. This might be something that you haven't done in algebra class before, but this is solving a quadratic equation by factoring it. There's at least one t in both of these terms, so I can factor it out, and I'm just going to cross it off. This is not something you do in algebra, but we can divide t out of this equation. And we get 0 equals 8.9 minus 4.9t. So to solve this, I add 4.9t to each side. I get 4.9t equals 8.9. And then to solve this, I divide by 4.9. And I get a time of 1.82 seconds. Okay, so there's time. And then the last part of my problem is to find x. Now there's no decision here. There's only one equation in kinematics that has x in it, for projectiles anyway, and it's this one. And so I will now plug in my known values. I will say x equals 0 plus 19 times 1.82. And that means that x is going to be equal to 35 meters. And so that is the distance that the soccer ball has traveled. So that's one walkthrough of a projectiles problem. And so you want to ask questions if you have them when you get a chance, but use this kind of template to try the first two problems in the angled launch worksheet. Thanks.